Here we go to C. Take a graph like showing on screen. As like previous videos, the graph will be travels from S root node to another fetched nodes. And they represents levels. From procedure graph. S to A to C, C to D, D to B to I, and I to J. These are in procedure non-sequential manner, then it's also called as iterative depending on depth first search in artificial intelligence. Time complexity O of B to the power of level. Then L equals to level. And B equals to breadth. Space complexity O of B into L. Whenever it's in not optimization mode, they represents to show like L is less than B. Iterative deepening depth first search, IDDFS, is a hybrid algorithm that combines the benefits of both depth first search, DFS, and breadth first search, BFS. In IDDFS, the search begins with a depth limit of 1 and gradually increases the depth limit in each iteration until the goal is found. This approach ensures that the search explores nodes in the order of their depth from the root, similar to DFS, while also guaranteeing completeness like BFS. By limiting the depth, it avoids getting stuck in infinite paths, making it suitable for large search spaces with unknown depths. Some advantages of iterative deepening depth first search, IDDFS, include 1. Completeness. IDDFS is guaranteed to find a solution if one exists, making it a complete search algorithm. 2. Memory efficiency. Unlike breadth first search, BFS, IDDFS uses memory efficiently by only storing nodes at the current depth, reducing memory requirements. 3. Optimal memory usage. IDDFS does not require storing the entire search tree in memory, making it suitable for problems with large or infinite search spaces. 4. Time complexity. Although IDDFS has a higher time complexity compared to BFS for finding the solution, it is more efficient than traditional DFS for large search spaces due to its iterative approach. 5. Suitable for large search spaces. IDDFS is well suited for problems with large or infinite search spaces where the depth of the solution is unknown, as it gradually increases the depth limit in each iteration until the solution is found. Some disadvantages of iterative deepening depth first search, IDDFS, include 1. Inefficiency in dense graphs. IDDFS may become inefficient in dense graphs where there are many branches at each level, as it explores the same nodes multiple times at different depths. 2. Redundant work. Since IDDFS repeatedly explores nodes at increasing depths, it may redundantly revisit nodes that were already explored in previous iterations, leading to wasted computational effort. 3. Ineffective for non-uniform edge costs. IDDFS treats all edges equally and does not consider varying costs associated with different edges, making it ineffective for problems with non-uniform edge costs. 4. Lack of pruning. IDDFS does not incorporate pruning techniques, such as alpha-beta pruning used in minimax algorithms, which can lead to unnecessary exploration of unpromising branches. 5. Poor performance in memory-constrained environments. While IDDFS is memory efficient compared to BFS, it still requires storing nodes at each depth level in memory, which may be problematic in memory-constrained environments or for extremely large search spaces.